Hello again. We proceed with physics 1015 tutorial number 9. So now this is question 5. So question 5 here is well, we are looking at incompressible fluids. All right, so for this type of fluids, we say that if you apply pressure on one end, that pressure will go throughout the liquid up to the other end. Okay, because you cannot compress this fluid. Whatever pressure you apply on one end must be equal to the pressure on the other end. So now we look at a system, a car lift, okay, in a service station. So in this car lift, it's like I made a model, a drawing of how it may look. So this is what it may look like. All right, so let me just shade it out. Hope it won't take much time. All right, so this is what we have. Something like that looks like this. All right, so you have your vehicle there on the right side, and then pressure is applied on the left side. Here we have force applied downwards. Okay, as you can see, you apply downward force on that end, which is producing an upward force, or rather pressure, on the other end. Okay, so now the surface area of the cylinder on the left is given as R1, which is 5 centimeters, and also the surface area of the right cylinder is given as R2, which is 15 centimeters. Okay, so now we want to find the force that must be exerted on the small piston so that we are able to lift the car on the right side, which has a weight of 13,300 newtons. So in this system, we have to find the value of F1. Okay, so how can we do that? Knowing that this is an incompressible fluid, when we apply force, or rather pressure, on the left, that same pressure will be distributed throughout the fluid until it reaches the other end on the right. Okay, so here we are using Pascal's principle. Okay, we have the force that is required to be lifted up, all right, which is 13,300 newtons. Okay, so F1 is what we are looking for. F2 is given as 13,300 newtons, and area is obtained as pi r squared. So area 1 will be given as pi r1 squared, and area 2 will also be given as pi r2 squared. Now notice that all these values must be in standard units. So if we have the radius in centimeters, we have to convert to meters first. Okay, and also, well, yeah, for this case it's just the radius. Okay, so Pascal's principle states that P1 must equal P2. Okay, so if P1 must equal P2, we have to expand. Also, we know that the pressure here is simply the force divided by the surface area. Okay, so we are saying F1 A1 must equal F2 A2. Okay, this implies P1 equals P2, from which, if we find an expression for F1, because that is what we are looking for, we are going to find F1 equals F2 by A1 divided by A2. Okay, so we know F2, which is the weight of the vehicle, and we also know the surface area for the left cylinder, which is the smaller one, and the surface area for the right cylinder, which is the bigger cylinder. Okay, so the area for the smaller cylinder is calculated with converted units from centimeters to meters, and we are getting 7.87 to the minus 3 cubic square meters. Also, area for cylinder number 2 is given as 7.10 times 10 to the minus 2 square meters. Okay, therefore if we substitute these values, we'll be able to obtain the value of F1, and we are going to find our F1 as 1470.5 newtons. Okay, so as you can see, there is nothing very difficult about this question. We simply apply Pascal's principle there. Then after that, now the question further says what air pressure will produce a force of that magnitude. Okay, so what pressure, in other words, will be applied on the smaller cylinder? Since F1 has been found, now we need to find P1. So what is the value of P1 that will be exerted as a result of the force that we just found? Okay, so again we go back to the expression for pressure. We know that pressure is given as the force divided by the area. Okay, so this is part B. Okay, so we know that pressure equals force over area. So this time we want to find the pressure which is applied on the left cylinder. Okay, because we have F1 now, we simply substitute the value of F1 and also the area of the smaller cylinder, giving us a pressure of 1.87 times 10 to the power 4 pascals. Okay, so this is the pressure that was exerted on the left cylinder.